The Olmec heads were scanned by AI. The results are unsettling. The software flagged something inside the stone that contradicted its programming. Researchers ran the scan again. Same result. Inside a 50-ton basalt head carved 3,000 years ago, the machine detected geometric precision that shouldn't exist. This wasn't a glitch. They scanned 16 more heads across different sites in Mexico. The AI found anomalies in every single one. Hidden features, impossible symmetry, internal structures that challenge our entire understanding of this ancient civilization. The data is now public. Other teams have verified the findings, and nobody can explain what they're seeing. Subscribe and hit like, because what the AI revealed gets more disturbing the deeper we go. What emerged from the scans defied every expectation. Surface markings inconsistent with any documented tool technology. Interior configurations never before detected. Details so precise they multiply questions rather than provide answers. The AI analysis hasn't resolved the mystery. It's intensified it. The evidence points to aspects of these monuments that fundamentally contradict everything we thought we knew about this ancient culture. Origins of the Olmec. This ancient society emerged along Mexico's southern coastline over 3,000 years ago. Their territory encompassed the Gulf Coast, particularly regions now identified as Veracruz and Tabasco states. Archaeological evidence places their sophisticated culture around 1,500 years before the Common Era began. This civilization constructed ceremonial complexes, developed symbolic writing systems, and produced monumental artwork. Their most recognizable legacy consists of the giant stone portraits. These sculptures represent faces carved from basalt, volcanic stone renowned for extreme hardness and tremendous weight. Each head originated from a single, massive boulder of this volcanic material. 17 specimens have been located to date. Every sculpture depicts a male human face bearing distinctive characteristics. The expressions convey calmness, the eyes appear narrow, and most wear what researchers interpret as protective headgear. The scale proves remarkable. The tallest specimen rises over 3 meters in height. The heaviest exceeds 50 tons in mass. Each emerged from one solid basalt block. These raw materials came from the Sierra de los Tuxtlas mountain range, located more than 90 kilometers distant from Olmec ceremonial sites. Mesoamerica possessed no domesticated beasts of burden during this period. The Olmec culture utilized neither wheels nor carts and lacked metal implements entirely. Despite these limitations, they transported these enormous stones across vast distances, then carved them using only stone implements. Contemporary archaeology struggles to fully explain this achievement. Multiple hypotheses have been proposed. One suggests river transport using wooden rafts. Another theory involves hundreds of workers dragging the blocks with rope and log roller systems. Yet no physical evidence confirms either method. The carving process presents another unexplained challenge. Basalt ranks among nature's hardest substances. Chiseling it without metal tools would demand thousands of labor hours. Despite this, the heads display refined craftsmanship. Facial features appear crisp and clean. Symmetry across eyes, ears, and mouths remains remarkably consistent. The facial characteristics suggest individual personalities. Many scholars propose they represent political leaders. Alternative theories suggest ceremonial guardians or religious icons. No definitive consensus exists. Beyond the heads, the giant portraits represent merely one category of Olmec large-scale construction. They also built enormous earthen platforms, stone thrones, and altars decorated with mythological imagery. They developed a symbolic system, potentially representing early written language. They crafted jade figurines and ceramics displaying sophisticated artistic quality. Yet despite these accomplishments, their ultimate fate remains unknown. The civilization declined approximately 400 years before the Common Era. Subsequent cultures, including Maya and Aztec societies, adopted many Olmec concepts, but the original people vanished. Understanding of the Olmec derives primarily from their material remains and what lies buried underground. These artifacts represent vestiges of an entire civilization, one ranking among the world's most ancient cultures. The heads remain the most celebrated and perplexing evidence of Olmec technical skill. Their scale, detail, and required effort exceed expectations for a pre-metal, pre-wheel society. Several heads display evidence of modification. Carving marks indicate some may have begun as different structures, like thrones or altars, before transformation into portrait heads. One head discovered at La Cobata appears incomplete. Its face shows rough texture, the carving unfinished. What circumstances halted the work? Until recently, archaeologists relied on surface studies, basic excavation, and visual inspection for analysis. These methods reached their limits, given the sculpture's enormous size and weight, which restricted how thoroughly they could be examined. The AI investigation begins. This changed when researchers deployed artificial intelligence tools to conduct high-resolution scans of multiple heads. These scans employed structured light, laser mapping, and density modeling to capture what human eyes and traditional tools could not detect. The technology enabled internal imaging, microscopic surface analysis, and cross-specimen comparisons. Initially, scans appeared to confirm existing knowledge. Then the software began identifying irregularities. Marks appeared on inner stone layers inconsistent with stone tool abrasion patterns. Shifts in internal density failed to align with natural basalt formations. In at least one instance, scans revealed geometric features beneath the surface that had never been detected previously. These elements weren't part of the known carving. They displayed excessive symmetry and depth. They remained invisible without scanning technology. The results proved unexpected, raising questions the current archaeological model cannot adequately address. While the meaning remains unclear, one fact has emerged. These heads are not simple monuments. The decision to scan the Olmec heads emerged from a need for more accurate documentation. In Veracruz State, Mexico, these sculptures face threats from erosion, vandalism, and gradual weather damage. Traditional documentation methods like photography and plaster casting couldn't capture complete geometry or surface conditions. Researchers therefore employed structured light scanning, laser surface mapping, and AI-based modeling. The objective was straightforward: create the most precise digital record possible of several heads. This would facilitate conservation planning, virtual restoration, and detailed study of tool marks, weathering, and structural changes over time. The original plan never anticipated discovering anomalies. The AI tools aim to enhance precision, not rewrite history. Technology and process teams deployed portable structured light scanners capable of mapping surface features at sub-millimeter resolution. After data collection, it passed through a trained AI pipeline. The algorithm had learned to distinguish between known carving marks, natural damage, erosion patterns, and environmental effects. The system would automatically flag areas where surfaces deviated from expectations. When the AI performed deeper analysis, it began generating alerts. One model flagged a repeated line pattern on a head's side, extremely fine parallel striations, visible only in three-dimensional mesh representations. They ran across the jaw beneath a decorative element. The markings matched no known Mesoamerican tool marks. They resembled abrasion scoring, seen in modern machining, though this comparison remains uncertain. No Olmec tools based on archaeological evidence could have produced such fine control. The marks proved too shallow, too consistent, and too protected from natural wear to be accidental. Another scan revealed a shallow recess near one head's base, circular and cleanly defined. This had never been documented because it sat beneath the sculpture's buried portion. When the model reconstructed the complete object, the shape became apparent. A socket-like depression, less than 5 centimeters deep. Its purpose remains unknown. No similar features have been reported in other Mesoamerican sculptures. In a third scan, the AI detected internal inconsistencies in material density. The head contained a small but distinct region inside the crown, where stone density dropped below normal basalt levels. The volume was irregular but enclosed. This could represent a natural void. Basalt can contain bubbles or gaps formed during volcanic cooling. However, the shape appeared more linear than spherical, resembling a channel or shaft, though the scan lacked sufficient power to penetrate fully. Verification and control. To check for scanning errors, the team repeated analysis using different models and software. The same anomalies appeared. They were physical object features missed for decades. As a control, the team scanned the known unfinished head at La Cobata. It showed expected tool marks, rough edges, and no anomalies. This confirmed the AI wasn't overfitting or generating false patterns. The system functioned as designed. The team also employed photogrammetry to check for subtle surface reliefs. By comparing lighting angles and micro shadows, they found what might be shallow carved lines behind one sculpture's ears. These lines formed a grid-like pattern, mostly invisible to the naked eye. The AI flagged this as statistically unlikely to be random. Another unexpected pattern emerged from symmetry analysis. The AI measured each face half to check alignment. Most showed natural variation, but one head had near-perfect bilateral symmetry in mouth and eyes, more precise than typical hand carving. This didn't prove machine use, but suggested a level of planning or measurement not previously documented in Olmec works. What makes this significant isn't one isolated detail, it's the pattern. Multiple anomalies across separate heads suggest the Olmec heads are more than carved portraits. They may contain architectural design, hidden structures, or reused stone. The scans also open new possibilities for understanding how the Olmec worked. If some heads were modified over time, their history is layered. Some features could date to different periods. This would reshape how we date and classify them. The next phase requires deeper scans, chemical analysis, and comparative studies. The heads aren't just artifacts, they're data structures. Only now are we learning how to read them. Impossible marks and buried geometry. The more researchers scanned the Olmec heads, the less consistent the data became. San Lorenzo also featured an enormous artificial plateau, visible as a very straight line in aerial imagery. Questions extended beyond external features. Something deeper was beginning to emerge. Elements that couldn't be explained by standard carving, typical weathering, or known construction methods from that period. One of the clearest examples came from a head at the San Lorenzo site. When the AI enhanced the scan's internal imaging using adjusted light reflection algorithms, it detected a pattern that shouldn't have been possible. Along the neck's inner curve, A series of symmetrical indentations ran vertically. Each was evenly spaced with identical arc shapes. The AI model couldn't match the pattern with any natural fracture sequence or erosion process. The hypothesis formed was straightforward. The indentations could represent either an inner reinforcement system or a pre-cut structure that guided the carving. But no known Mesoamerican technique matches this kind of internal shaping, especially not in basalt. This stone type doesn't lend itself to internal design work. It's too hard and cracks under stress. Creating interior features without compromising the outer surface would require understanding of stress distribution well beyond any known tools from that era. Another anomaly emerged from material composition. A separate scan using portable X-ray fluorescence revealed irregularities in mineral content on one head's outer layer. Specifically, traces of hematite and magnetite appeared in a polished strip extending across the forehead. These minerals aren't unusual in Mesoamerican pigments, but in this case, they weren't surface applied. The elemental signature was embedded in the basalt's top layer, suggesting introduction during carving, not painted afterward. The forehead band. The distribution of these minerals formed a band that was slightly raised. It didn't appear decorative. It didn't follow the headdress contours or any visible ornamentation. It cut across features. Under AI-enhanced scans, the surface had fewer microfractures than adjacent areas. The system flagged this section as anomalous. What makes this detail important is its location and consistency. Other heads showed no such feature, only this one and only in that band. The theory that it was natural stone variation was ruled out after control samples from the same quarry showed no similar patterns. In a third case, a scan from one head's back revealed what appeared to be a faint recessed spiral. The groove depth was less than 0.5 millimeter, but it ran continuously for almost 1 meter in length. The spiral had 5 complete turns, expanding outward from a central point near the crown. No previously studied Olmec artwork includes such a pattern. Spirals appear in other Mesoamerican art, often symbolizing water, wind, or time. But their appearance on a head and on a non-visible section is unprecedented. Some researchers believe at least one head was carved in multiple stages using different tool types. This observation supports the theory that heads might have been recycled, possibly starting as thrones or monuments, then reworked into heads. This would explain certain inconsistencies in geometry and tool finish, but doesn't explain why inner marks or hidden spirals exist. If they were leftovers from previous forms, they should show signs of partial erasure. Instead, they appear intentional, preserved. Material analysis. The basalt used in this sculpture had unusual grain structures. When compared to control samples from the known quarry region, the match was incomplete. Most basalt in Olmec heads comes from the Tuxtlas range. This sample had higher feldspar levels and slightly different magnetic properties. This suggests either the source was a different part of the range not previously mapped, or the stone came from farther away. What ties all these anomalies together is their invisibility to the naked eye. No archaeologist studying these heads by sight could have spotted them. Only when AI-based scanning systems reconstructed their form with sub-millimeter detail did these features appear. The scans reveal a structure and complexity in the heads that wasn't previously documented. The implication is that either the Olmec had more advanced techniques than we've given them credit for, or the heads have a more complicated history than previously assumed. Perhaps both. What the AI scan has shown isn't a supernatural artifact. It shows a sculpture possibly designed for something other than public display, and the more we scan, the more these buried designs continue to appear. The original purpose of the Olmec heads has always been uncertain. Most experts believe they were carved to represent rulers or elites, possibly to mark territory or commemorate political power. This is based on the head's unique facial features, elaborate headdresses, and their placement in central areas of known sites. But the new AI scans, along with the anomalies they revealed, suggest a more complicated role. These heads may have served a second function, one that goes beyond public symbolism. At La Venta, 4 heads were discovered buried in a large ceremonial platform. That kind of treatment doesn't fit with the idea of public display. Instead, it suggests a kind of burial, a sealing or hiding of something once active or sacred. The choice to bury them may have been intentional, not accidental. They weren't discarded. They were put away. Signs of ritual transformation. Some heads show signs of defacement. Facial features were flattened or chipped away. These changes were deliberate. One theory is that these heads were damaged during political change. When a ruler fell from power, his image was defaced. But another possibility is that the heads were part of a cycle, created, displayed, buried, and perhaps even reused. If this is true, then they weren't just statues. They were ritual tools involved in events repeated over generations. AI analysis also revealed symmetry patterns suggesting mathematical planning. One head displayed perfect alignment between eyes, nose, and mouth down to sub-millimeter scale. This level of precision is rare in freehand carving. It implies some kind of layout system. A few researchers believe this could point to modular carving methods or templates used to guide sculptors. That means the heads weren't just art. They were measured, calculated, and executed with architectural care. That pattern also reflects in the head's orientation. At least 5 face cardinal directions: north, south, east, or west. This is common in Mesoamerican sacred planning. Temples, ball courts, and plazas were often aligned with solar or astronomical markers. If the heads were part of a larger spatial design, then they may have served a cosmological role, not just to show who ruled, but to connect earthly and celestial order. One of the most unusual findings from the scans was the detection of recessed symbols on a head's back at Tres Zapotes. The symbol was only a few centimeters wide, barely visible even under raking light. It looked like a cross inside a circle, not found in other Olmec iconography. No one knows its meaning. Some suggest it could be a directional marker. Others think it may have been part of a system used to align the head with other objects in space. Either way, it doesn't seem decorative. It was placed in a hidden location, not meant to be seen casually. Memory systems. There's also growing interest in the idea that the heads were part of a memory system. In some early societies, monuments were used to store information. Position, scale, shape, and order could carry encoded meaning. If the heads were laid out across ceremonial grounds, according to a specific geometry, they could have served as a kind of spatial archive. This would make them part of a living knowledge system, not static memorials. The theory gains weight when comparing the heads to other Olmec structures. Several platforms and mounds at San Lorenzo and La Venta follow proportional patterns. Some are aligned with river paths. Others mirror solar angles at key points in the year. The heads fit into these alignments even when buried. That suggests the planning behind their placement wasn't random. Another point supporting multiple functions is evidence of head recycling. At least 3 heads show signs of being recarved from older monuments. Tool marks that cross at odd angles, surface polishing that overlaps earlier edges, and unfinished facial contours all point to reuse. One head has what appears to be a throne seat carved into the back, now barely visible due to surface erosion. This feature wouldn't exist if the block had been shaped only once. If the heads were recycled, that means they weren't sacred in a permanent way. They could be transformed, reshaped, and repurposed. That flexibility suggests they served a role that changed with time, tied to social cycles, power shifts, or ceremonial needs. This again pushes against the idea of them as static monuments. They were active objects, possibly used across multiple generations. New perspectives. None of these interpretations can be confirmed with full certainty, but the scans revealed features that the public and even experts had missed for decades. If the Olmec heads were only meant to be portraits, their construction, placement, and reworking don't follow expected patterns. Their size, materials, and orientations match other sacred structures more than decorative art. Their surfaces contain details too fine for casual display. Their locations match ritual geometry, not random spacing. Whether ceremonial, astronomical, mnemonic, or architectural, the heads don't stand alone. They're connected to the land, to the stars, and to each other. They may not have been built to be seen. They may have been built to hold meaning. Technology's purpose isn't just to observe, it's to reveal. In the case of the Olmec heads, artificial intelligence didn't find an answer. It found something else. It uncovered a pattern of mismatched details, inconsistencies, and hidden structures that suggest a deeper truth, one that has remained buried not only in soil, but in the assumptions behind centuries of study. From the beginning, these sculptures defied expectations. Their weight, their scale, and the skill used to create them placed them far beyond what most would assume of a culture with no metal tools, no wheels, and no written records. But archaeology accepted the mystery as a sign of creative ingenuity. The heads were seen as bold examples of early art, powerful, yes, but simple in meaning. The pattern emerges. The new scans have changed that. What the data shows isn't a single anomaly. It's a series of them. In nearly every head scanned, some detail didn't match the expected profile. It might be a thin groove buried in the stone. It might be a void inside the structure. It might be a line of mineral concentration that didn't belong. Each anomaly on its own isn't enough to rewrite history, but taken together, they form a message. That message is simple. The current model is incomplete. The most surprising discovery wasn't on the surface, it was within. A model trained to simulate internal density based on laser reflection and surface geometry revealed inconsistencies in two heads. One had a hollow segment close to the center, long and narrow like a hidden shaft. The other had layers of material that didn't match known basalt patterns. In both cases, traditional explanations failed. These weren't random air pockets. They were too symmetrical, too isolated. Some researchers suggest these features are natural. Basalt can crack during cooling. It can form pockets, bubbles, or stress lines. But none of those forms match the layout of the voids detected here. One scan showed a clean break, a flat internal surface aligned with the external base. This isn't how natural voids form. It looks cut, controlled, measured. When the results were published in a peer-reviewed archaeology journal, the academic response was cautious. The authors didn't claim anything supernatural. They didn't suggest lost civilizations or advanced machines. They reported the data. They described the process, and they admitted the limits of their interpretations. Growing interest. What followed was a wave of curiosity. more teams began requesting access to the AI models. Funding applications were submitted for further scans, and slowly, more anomalies began to emerge. One team discovered what appears to be an etched line under the jawline of a San Lorenzo head. Another found a polished depression hidden beneath the chin of a La Venta sculpture. None of these details were visible to the naked eye. None had been noted before. Even more troubling were the toolmark analyses. In at least one head, the AI flagged patterns that matched no known carving technique. The surface bore signs of grinding, not pecking, not chiseling. Grinding requires abrasion tools and fine pressure control. The Olmec did use abrasives on jade, but to do the same on basalt at such scale would require a supply of tools and materials not currently found at any site. The AI also detected symmetry too precise to be explained by hand carving alone. One head's facial axis deviated less than 2 millimeters across the full width from ear to ear. For context, this is closer to architectural tolerance than typical sculpture. It's unlikely the human eye alone could maintain this consistency. The spiral detected in one head's recessed back remains unexplained. Its curves followed a mathematical arc. Not random, not decorative, a deliberate pattern hidden on a surface not meant to be seen. Together, these details suggest the heads were more than visual. They may have encoded something, not writing in the modern sense, but form-based data. The way lines and shapes carry meaning in architecture, in ritual layout, in spatial memory systems. Knowledge in stone. In many early cultures, knowledge wasn't written. It was built, in the shape of roads, in the placement of stones, in the silent language of geometry. This raises the possibility that the heads are part of a larger system, a system we've only begun to map. Their orientation, their internal structure, their unseen features all point to layers of design. Layers not required for public viewing, but for function. What that function was remains unclear. It could be ceremonial, it could be symbolic, it could be practical, but it wasn't random. The use of artificial intelligence here doesn't mean the past is unknowable without machines. It means our assumptions must evolve. The heads have always been silent, but now, under light and lens and software, they're speaking. They tell us that ancient craftsmanship included choices we didn't expect. That sculpture could serve multiple roles, seen and unseen. That form could carry knowledge long after the makers were gone. The Olmec legacy. The Olmec civilization disappeared more than 2,000 years ago. Their language, their records, and much of their daily life have vanished. What remains are the structures they left behind. The heads are the most powerful of those. Now they're revealing a second layer, not because they changed, but because we finally looked closer. The anomalies are real. The data is clear. Something is off. There are features that don't belong in the current timeline. Marks that suggest precision beyond what we found in their tools. Materials that imply planning beyond what we assumed. Patterns that echo logic, not accident. None of this proves anything impossible, but it shows that something we once thought we understood may be far more complex. The story isn't over. It's just beginning. These scans are now public. The models are being refined. The next step is to re-examine not only the heads, but the land around them. The platforms, the buried plazas, the forgotten foundations. What else is sealed beneath stone? What else have we misread? The heads were never just monuments. They were never just art. They were pieces of a system. And now that system is beginning to show itself. What we do with that knowledge will decide what we find next.